Section 3.2 is all about graphing square root and cube root functions. We should see a lot of the same patterns occur in square root and cube root functions as we've seen in every other function we've graphed so far this year. But to get started, let's start by just graphing the parent function. So we're going to start off by graphing plain old square root of x and plain old cube root of x. And in order to see what those graphs look like, let's start off by making a table of values. So starting with my square root function, I'm going to plug in these x values on the side by taking the square root of them. So if I plug in the number -9 and I ask myself, what is the square root of -9? I know that that does not actually exist. You cannot find one number times itself that will give you a negative number. So that means that I cannot take the square root of -4, and I cannot take the square root of -1. But I can take the square root of 0 to get 0. I can take the square root of 1 and get 1. I can take the square root of 4 and get 2. And I can take the square root of 9 and get 3. So notice when I made this table of values, I only picked nice numbers for the x that I could easily take the square root of. When I graph these points then, I'm going to have a point at 0, 0. I'll have a point at 1, 1. Then I'll have a point at 4, 2. And a point at 9, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 3. So our square root function is going to start at 0, 0. Again, we're not going to be allowed to have any negative x values in this parent function, but it can continue on forever to the right. So if we remember back from section 3.1, when we were talking about inverses, when we took the inverse of this x squared function, we got this non-function inverse relation. So what we're really graphing when we're graphing the square root of x is we're just graphing this top section of that inverse function. For cube root functions, again, I'm going to try to plug in some values to see what I get. If I plug in -27, I can take the cube root of a negative number. The cube root of -27 is -3. The cube root of -8 is -2. The cube root of -1 is -1. The cube root of 0 is 0. The cube root of +1 is +1. The cube root of +8 is 2. And the cube root of 27 is 3. So in this case, I don't have a restriction on my x values and I don't have a restriction on my domain. So that means I can graph all of these points if there's room. I'm probably not going to have room to graph that -27, -3, but I bet I can fit -8, -2, 1, 2, 3, 4, 5, 6, 7, 8, -2, -1, -1, 0, 0, 1, 1, and lastly, +8, 2. 1, 2, 3, 4, 5, 6, 7, 8, and up 2. And again, we'll kind of connect our points in like a little sideways squiggle this time. And again, if we look back at our notes from section 2.1, that's the exact same thing we got here when we switched our x and y values on the cubic function. So it's important, again, once we have our parent function, to talk about some of their features. The domain of a square root function is restricted to just 0 to infinity. The range on my square root function is also restricted from 0 to infinity. And yes, it is 1 to 1 when we only have that half of the graph. For the cube root of x, my domain and range are both unrestricted. They both go from -infinity to +infinity, and it is 1 to 1 as well. So it's important to notice that these have similar patterns to our quadratic functions and our cubic functions. If we remember when we graphed those functions, we talked about over and up patterns, and since these are the inverses, those patterns are just going to switch. So when we graphed our function for x squared, we had over numbers that we used from our vertex and up numbers, like 1, 2, and 3. And when we went over 1, we went up 1. When we went over 2, we went up 4. And when we went over 3, we went up 9. But now when we graph the square root of x, those numbers are just going to flip. So this time, over 1 and up 1 is still the case when we start at this initial point. But then we're going to go over 4 spaces and up 2 spaces, over 9 spaces and up 3 spaces. Similarly, if we think about our cubic function, our over and up patterns, we're over 1, up 1, over 2, up 8, and over 3, up 27. Again, this time when we graph the cube root function, we are switching those values. So this time we would be going over 1, up 1 still from this middle point, from that point of inflection. But now we're going to go over 8 spaces and up 2 spaces. And if we have room, which I highly doubt, we would go over 23 spaces, or I'm sorry, over 27 spaces and up and down 3 spaces. So knowing those patterns now, we can graph with transformations, specifically stretches and compressions. Just like we have seen in all of the rest of our functions this year, these two functions are going to have a, h, and k values, where a is the number out in front, meaning it's going to be a vertical stretch or compression. So if I look at this function, 2 times the square root of x, that means I would have my square root function, but I'm stretching it by a factor of 2. So if I think about my overs and my ups, I can still go over 1, but this time I'm going to go up 1 times 2. And I can still go over 4 spaces, but this time I'm going to go up 2 times 2. And lastly, I can still go over 9 spaces, but this time I'm going to go up 3 times 2. So I will start at this 0, 0, and then follow my pattern. Over 1 and up 2 spaces. Over 4, 1, 2, 3, 4, and up 4 spaces. 1, 2, 3, 4. I don't have room on this one to go over 9 and up 6 spaces, so I'm going to call it good there. For the second one, I'm going to actually skip it for now and have you guys do it, but I'm going to move on to this cube root function with a vertical stretch factor of 4. So we've got our overs and our ups for a cube root function. So if I copy the table from above, I've got 1, 1, and over 8 and up 2, but now I'm multiplying those values by 4. So if I start at my point of inflection, I would go over 1 and up 4 spaces, 1, 2, 3, 4, and over 8, up 8 spaces, which I don't have room to do, but I know it would be somewhere over here. Then I go the opposite direction, left 1 and down 4. Opposite direction, over 8 and down 8 would be something like this. So as you can see, this is a much narrower graph, or a much taller graph, I would say, than the original. Okay, what I would like us to do now is pause this video and try to do this graph on our own. So think about what the parent function is and what you would be doing to all of those up values. So we've paused our video, we've tried this on our own, and your graph should look something like I have here. Notice again this time that this negative value out in front makes our graph a reflection, just like it has for all of our previous functions.